So we're going to use this equation here. 1/2 times the quantity of 7x minus 6 equals 6x minus 10, for example, here to help you out. So there's my original equation here. Let's go and get the writing tools out, and there it is. We'll be using our equation letters to guide us through. So you should have that out. I have mine out, the letters A, B, C, D, E, and F. There's a new letter G for find the product, but that won't really be used here, so we won't talk about that much. All right, so let's go ahead and attack this problem. So I had that original equation up there. What I want to do is use letter D. Letter D says find a multiple of the denominators and use that multiple to find all fraction numbers. Excuse me, not to find, to turn all fraction numbers into whole numbers. Well, here's some good news. I've only got one fraction. So the LCM by default becomes whatever the denominator is there. What's the denominator? 2. What's my least common multiple in the situation? 2. So notice, 2 apply there and 2 apply there. And notice how I put the parentheses brackets to indicate multiplying this quantity from up there. Didn't need it until now. So notice how we do have to introduce those sort of the brackets for the distributive property to be applied. So that's letter D. So let's go ahead and take a look. Boom, that's gone. Hey, how did that magically go? It's not magic. Let me direct your attention to over here. Let's take a look. I have 1/2 here. I need to change this. I need to get rid of the denominator in a sense, or cancel out and turn this to a whole number. Well, we know the only denominator here is 2. So I'm going to go ahead and use 2. Well, any whole number can be turned into a fraction number. So notice 2 over 1. Well, how many sets of 1 are in 2? 2. Notice again, if I make it a fraction, I can turn it immediately back into a whole number, turn back to a fraction, turn to a whole number. You get the idea. So that's the reason why. And sometimes this makes students nervous. Like I said, you can just go like this, 2 times 1 over 1 times 2, and you can see the cancel out. How come that don't cancel out, Mr. Heath? Well, it becomes 1 over 1. And if we divide, well, how many sets of 1 are in 1? 1. So that's why really it just turns to a single one and never really cancels out when it comes to the digit 1. All right, so now we know why that turned into all of this down here. Had a lot of work. We went ahead, canceled out. That left us with just 1 in this situation, and 1 times that quantity there gives us the same amount. I'm going to erase this up so we can go ahead and talk. All right, so we've taken care of applying distributive property, well, excuse me, by canceling out the fraction over there by using the whole number. Well, what we do on one side, we got to do on the other. So we multiplied over here. We multiply over here as well by 2. So smart cut, apply 2 sets of 6, 12, drag the x, done. Let's go over here. Now remember, we're multiplying, so you notice I have 1 negative. Well, that's an odd amount of negatives, therefore my product is going to be negative. 2 sets of 20, that's going to give you 20. So at this point, we are done with our letter D. Actually, you could say letter D and C. Why? Because I had to apply LCM, but in the process of applying the LCM, I actually use distributive property as well. So we'll call that a C and a D. So let's move on down. Let me put my little separation line. And you can notice here, I've made a choice. Looks like numbers, integers, constants, whatever you want to call them, are going to be on the left-hand side. And my variables, they're going to be on the right-hand side. So let's play the game. Let's get all the numbers to one side, constants, integers, whatever you want to call them, and let's get all the variables over to the right-hand side. So let's begin. So I want my variables over there, so let's go ahead and remove variables from that side. How would I do that? If I have 7 positives on the number line, I need how many negatives to get to 0? I need 7 negatives. If you're using arithmetic, that's going to be 7 minus 7, which gives you nothing. What I do on one side, I'm going to go over there and do it to the other. So if I use just arithmetic, I'm going to say 12 minus 7 equals 5. If I think algebraically on the number line, I'm at 12. If I have 7 negatives, that puts me at positive 5. So either way. And so now we've done that work. Well, I didn't touch the negative 20, so the negative 20 comes down. So hopefully that gives you clarity on that one. So we're at D and C. At this point, I did an inverse operation. That's letter A. Now, what did I do the inverse operations with? I did with variables this time. Did you notice? Negative 7x here. So let's go down to the next one. Remember, we still want the numbers on this side. Still want the variables on the right-hand side. So I've got to do another inverse operation, or letter A. And this time I'm not going to do it with the variables. I'm going to do it with the constants, integers, numbers, however you see it. So I'm going to go ahead and take that negative 20. So negative 20, well, if I'm on the number line, I have 20 negatives. What do I need to get to 0? 20 positives. If you're using arithmetic, 20 minus 20 leaves us with nothing. What I do on this side, what I do on this side, I do on the other. I have 20 positives on the right-hand side. I must have 20 positives on the left-hand side of the equal sign. So in this situation, if I use algebraic thinking, I have 20 positives, I have 6 negatives, or I have 6 negatives and I have 20 positives, I have 14 positives. If I'm doing arithmetic, 20 minus 6 gives me 14. All right, and last but not least, guess what? FB, baby. We are finally at the point where we are getting down to the variable by itself on the right hand side and the number, but we're not quite done yet, because notice I still have a constant there that's not the invisible uno. All right, so in the end, remember, variable by itself with an invisible uno, that's positive. So let's go ahead and do that. So letter E. So what is the coefficient here? I see 5. So FB by 5. I caught the eyeball check. Well, my eyeball C is 5 here. Divide by 5 there as well. That finally gives us our invisible uno. Okay, our invisible 1 here. So let me go over here. What we do on one side, we do on the other. All right, so do a little wind up. Find the quotient of 14 and 5, and it's 2.8. And there's my solution. So there we are. Solution. I hope this helps you out. Go back, use your little, algebra letter things to guide you. D, C, A, and E, and you got the solution to this.